Hello. Today we are going to talk about another sorting algorithm called selection sort. Let's start. This is the pseudocode of selection sort. Read it once, pause the video just to get the general idea how selection sort works, and then we will see it animated where I will mention these steps. So let's see the selection sort in action. Here we have unsorted array of 5 integers. Just as the pseudocode said, we will go through each of the elements trying to determine the lowest value. As we move from element to element, we will keep the variable updated with the lowest value we have encountered so far. So let's start. 29 is the first, and because of that, the lowest number we have encountered so far. So it's marked in red because it's stored in a variable as the lowest number. Actually, its index 0 is stored, but just for the ease of the explanation, sometimes I will use the word value, sometimes index. So next step is, which is also a part of the first step, is to move next. Now compare this value with the value stored in a variable as the lowest value, since the 10 in this case of course is lower than 29. We will set 10 as the lowest value in the variable. So we move on. 14 is bigger than 10, so we do nothing, we move on. 37 is also bigger than 10, so we move on. 14 is also bigger than 10, and with that we finished first pass. In this pass we determined that the 10 is the lowest value, and we stored its index 1 at the variable that keeps track of the lowest value, actually the index where the lowest value is. In this case it's index 1. So the next step from the pseudocode, step 2, is to swap this value with the value at the index we began the pass with. Since we began the first pass with the index 0, we will swap 10 and 29. And with that we have sorted number 10, and it will be ignored in the next pass. Now let's do the second pass. Again, 29 as the first value in this pass is stored in a variable as the lowest value because it's the first value in this pass. We move one index to the right, we compare 14 with 29. Is it smaller than 29? It is, so the variable will be updated and it will contain 14 now. We move one index to the right. 37 is not smaller than 14, so we move on. 14 is not smaller than 14, it's equal. So in the second pass we determined that the lowest value is the value 14 and index 2. Actually we stored index 2 in the variable because it contains the lowest value, as I already said. So the second step from the pseudocode is to swap this value with the value at the index we began this second pass with. And since we began the second pass with index 1, first unsorted value, we will swap 14 and 29. And 14 is also now sorted and it will be ignored in the next pass. Let's move on to the next pass. Again, same process. Compare 37 29. 37 is bigger than 29, so we move on. Compare 14 with the 29. 14 is smaller, so 14 will be stored in a variable as the smallest value, and we finished this pass also where 14 is determined as the smallest value. And step 2 is to swap this value with the value at the index we began this pass with, which is index 2. And 14 is also now sorted. And the last pass, compare 29 with 37. 29 is smaller than 37, so we will update the variable to contain 29 since it is the smallest value in this pass. And step 2 is to swap these two values, and with that we finished sorting this array. This is the pseudocode of our implementation, which will be in JavaScript. Read it once and pause the video, and then I will show you the actual JavaScript code. This is the implementation of selection sort in JavaScript. Now that you have seen how selection sort works, it shouldn't be that hard to understand it. And finally, we talk about big O notation of selection sort. Here is basically everything you need to know. Read it, text is pretty clear, and with that we finished another sorting algorithm. And take care, and see you in the next video.